Good evening friends. Now we will be continuing our lecture on ANOVA. We have already did this part where, as you can see on the screen, we have solved it using pen and paper and also through the software. Now going ahead, now we have to understand, as in the t-test there are two sort of designs, independent and the dependent t-test, and there was obviously one sample t-test. But when we come to groups comparison, there are two sort. One is the paired sample and one is the independent sample. The paired sample is also called independent. Paired sample is also called dependent. Okay. Now, similarly, ANOVA repeated measures is same subject is tested again, that is a paired sample one, and between subjects is the independent sample one. Okay. So, please understand there is nothing new about it, is just the terminology when we go to the when we go to the ANOVA softwares, that is what it differs. Okay. As you can see, same the between subject question, do different teaching method result in different test scores? Does a new teaching method result in improved test score? So, when we say a new teaching method, that means already there was a teaching method and we are comparing with on the same subject. As we said, subjects are tested under multiple conditions, as we told that treatment 1 and treatment 2 what we used earlier. Now, coming back, this is what we have talked about. Okay. A repeated measure is built upon paired sample t-test and between subjects is built upon independent sample t-test. Now, how do we do this? Okay, now let us assume, understand, this is independent sample. We have already done the independent sample t-test earlier. This is the paired sample one or the repeated measures. So, there are 30 participants, 1, 2, 30. Then we have different techniques applied on them and we have getting scores for that. Okay. Now, how does the calculation begin if we have to use pen and paper by ourselves? Okay. So, first thing is that, as the hypothesis is that mu A is equal to mu B is equal to mu C, okay, which ultimately translates into 3 categories in this case. Okay, when for 3C2, so 3C2 is 3 here. Okay, A minus B is calculated, B minus C is calculated, A minus C is calculated. Okay. Now, the only question is, are these 3 zeros or not? A minus B is 0 or not, A minus C is 0 or not, or B minus C is 0 or not. That is a simple thing. Okay. Now, please remember the way we calculated the within errors in the repeated measures was multiplying, was like obtaining the grand mean subtracted by the group mean and squaring that up and multiplying it by the number or degree of freedoms, okay, and summation. Similarly, that happens here. So, now this represent validity of scores. So, now this is sum of squares, we will get that. Okay. Now, degree of freedom is very simple. We have 30 samples. So, 30 are entries. So, for per testing per column, we have 29, 29, 29. So, 29 plus 29 plus 29, that becomes 87. So, degree of freedom is got, error we have got, okay, and in that way mean square error within we get. Okay. So, that translates to 18.9. Now, again simply how do we get the between numbers? This is the within numbers. If you remember, the within number was there in the between numbers, or within numbers is called the treatment and between numbers is called the, sorry, within number is called the error and between number is called the treatment. Okay. So, these are the between numbers, same calculation as earlier in the independent sample test. Okay. So, 30 times entry is there and those sort of things we are assuming. Okay. Grand mean is calculated. Okay. Then sum of squares of between, again you can see 10 times, okay, because their number 10 times are repeating, okay, for all of them. okay, because there are 10 sort of entries. So, 30, 30, 30, the 10 types of numbers are repeating, okay, and the degree of freedom is again as we say 3 minus 1, because there were 3 groups, okay, 3 minus 1 is 2. So, we can get the between, okay, entry. So, in this way we can get, please see, this is what we have got. Now, as we told you earlier that on paper and pen what we do, we just get the f value and then we go to the table, okay, f value for degree of freedom 2 and 87. Now, we see degree of for the degree of freedom 2 and 87 and alpha 0.05. Okay. So, we can calculate, go to degree of freedom on denominator is numerator is 2 and 87 will be somewhere here between 60 and 120. So, something between. So, what we can do 60 and 80 we can divide in equal proportion. If 60 is 3.15 and 120 is 3.07, then what will be 87. Okay. So, in this way we can find out and it will something like 3 point something. Okay. Now, this was the pen and paper method. What we can do, as you know, please see, here is the difference we have to understand. Here we are using the function QF is equal to 0.95, because I am not interested, please understand, as I was telling you, this is what the pen and paper, the paper based test generally shows, okay, and we have to verify it by the image also, please see here. Okay. So, we are looking this for 0.05. So, what we are looking this for is 0.95. Now, the software tool will give us the value for this. Okay. So, therefore, we will write 0.95 comma 3, not 3, I suppose it is 2. Let us check it. Degree of freedom is 2, yeah, comma 87. If x is equal to 1, x plus 2 is this. Okay, fine. QF 0.95 comma 2 comma 87 is how much? Yeah, we got it, 3.101. Okay. So, this is getting the cumulative for the F table. Okay. This is what we have to understand, that ideally the ANOVA table, now we will do that also. The ANOVA table is very simple, we just have to do y on x and we will get it. So, let us try that. Let us see where is our data with us. Yeah, repeated measures in this. Okay, let us download this. Let us open the file. So, this is what we had. So, please see, there are 3 groups A, B and C. Okay. Now, please again understand, here if you see the data looks like as if it is a independent sample t test, independent sample ANOVA. Why? Because the data is again in 2 columns, one is the marks and another is the grouping. So, now the what we say, the skill lies with the researcher. So, what we do, if we import this file, let us do this, import this file, CSV file, we go here, we browse downloads. Okay. See. So, this is our data. Okay. Now, let us go to teaching parameter text. means ANOVA. Now, here is where we have to get the catch. Now, we are looking for this. So, groups come here and number come here. Okay. Let us first do the between one. Let me show you that what I was trying to tell you. The number come here, the groups come here. Okay. And if I submit it, what is happening here? Okay. So, we are getting this. Okay. Two groups are there, to a degree of freedom 287. Now, please understand here the degree of freedom things is not that much different. Let us try it again. This is, please understand, independent sample or between subject. Okay, that is what we clicked. Let us try here parametric test ANOVA, repeated measure. My data. Let me just check what is my data. Nothing. Yeah. Run again. Between subjects. We have to understand this concept just like we did it here. Okay, and calculated that table. Okay. Now, what is more important is to understand. So, this is our test, there are two groups, okay, and we know 0 is there in between. So, please see, this is the way it is calculating. Now, what I wanted to say here is, yeah, please here in the workspace, yeah, in the workspace. You can say A ANOVA results is equal to AOV, I think, yeah, my dot CSV dot data dollar num. This will be, this is a sign to say that y is dependent on x. Dollar number is the function, yeah, group. Okay. Now, please see, there is a variable called ANOVA results. This is I was expecting in the machine, yeah. This variable ANOVA results is generated. Okay. Now, what I am trying to tell you that you could have saved the results. So, here everything can be checked. Okay. As you can check here, degree of freedom of the quartiles, okay, different residuals, the effects, the fitted values, okay, and the coefficients. Okay. In this way, we can save the results of a ANOVA table. Now, there is something more interesting to us apart from repeated means. Generally, we do not in social sciences do repeated means measures. It is done in medical sciences or where there are experiments. So, therefore, in most of the classes you will see only one way ANOVA or at max in the between subject ANOVA. Okay. Now, I need to tell you one thing that as ANOVA is there, that one of the variable is scale is discontinuous or ordinal or nominal. Okay. Then we have n way ANOVA. N way ANOVA is if the number of factors, independent factors are more than 2, that is it. that is NV ANOVA, and MANOVA is when there are multiple independent factors. So, we will not be doing MANOVA. Okay, this is just for information. MANOVA is a very high advanced technique. We are primarily doing ANOVA, and that too only two-way. Okay. So, three-way means three variables independent, two-way means two variables. Okay. So, we will be doing three-way ANOVA. Okay. So, this is the file we will use. See, let's try it out. Download again, is downloaded, we read it. Now, here we have to change the file name my.NANOVA. Okay. Let's retry it. ANOVA data. Okay. And here we change it ANOVA and we submit it. Now, please look at this ANOVA data. See, this is the data. So, numeric string. So, these are the numbers. Okay. Now, there are three on treatment, dose and yield. So, what we are trying to say, yield is dependent on dose or on treatment. Okay. As it is very simple, type of treatment is ABC that we discussed. Now, there is also factor apart from type of treatment, there is category of dose, low dose or high dose. Okay. So, now there are two independent factors, one is the type of treatment, another is the type of or the quantity of dose. Both of them should give to yield. Okay. Yield is a dependent variable. So, we go for ANOVA, we select here ANOVA, our yield is a dependent variable and our treatment and dosage is the independent variable. Let us try this. I do not know why this is not working here. ANOVA paired comparison test option. Okay. See, this is working here. I do not know if it is created. It is not creating the file, no problem. That is not an issue. Softwares have these things. Okay. Now, please see here what is happening here. We have taken 30 entries of ABC and we have also diluted them with a low dose, high dose. Okay. Now, what it does is low A minus high B. So, all sort of combination, because there is low A, there are 6 groups possible. Okay. There are 6 groups possible, like low A, low B, high B, low C, high C. 6 groups are possible, and then there is difference of test between these two. So, we do 6C2. So, that is what we will do. We will do 6C2 which is equal to 15. Okay. So, 15 is the number, that is what we are needing here. So, these groups are 15 number 3, 3, 3, 6, yeah, these are 15 groups. Now, the testing is going here in NV ANOVA. Ultimately, you can see this is what we have to figure out, that yeah, this p value. So, p value is saying 0.16. What it means, at 95% confidence, we cannot say they are different, and that is what is happening. See, the 0 is lying in on confidence intervals, as we can see lower limit, upper limit, and you can also see here all of them are more than 0.05. All of them are more than 0.05 and the lower and upper limit contains 0. Now, best point is, you see we are getting 16.16. So, let us get back. Now, again this is the command we have to use. So, I will use it again, ANOVA model As I told you, GUI R and command line R both are required. We chose R keyword because it is most primarily GUI R. However, there are people who just use command line R, as you can see, ANOVA AOV. Okay. The file name is N ANOVA data yield please pay heed here, N ANOVA underscore data dose, okay, group. Just check the N ANOVA data, which is here. Yeah, treatment. Okay, treatment is the word. Star N ANOVA underscore data dose. Okay, there, yeah, please, there is one error. This is this way. Yeah. Okay. Now see, N ANOVA model has been created here, and now we will see summary N ANOVA underscore model. Okay. See, same things are repeated. Okay. The p value is again for the complete test. You see, there are two things. One is the treatment. How is treatment affecting? The one way with the between group with treatment, the between group with dose, and then combination of them. All three of them are not significant. Why we are saying? Because the p value is more than 0.05, okay, which tells that nothing is affecting. Okay. So, in that way there is no significant effect of. Okay. Now, this is where we need to get into interesting part. Now, what is happening here? Please see. Let's talk this. Let's talk about something called interaction. Okay. So, suppose in this case we say that yield is affected by dose in one study. In second study, we can say yield is also affected by the treatment. Okay. Now, what this means that when both dose and treatment are there, then the yield should increase. Now, let us get into very simple things. So, suppose there are two dose, low and high. Okay. So, yield increases when dose increases and yield increases for different treatments. So, what does this mean? Suppose there is dose low and dose high. There are two levels of dose. The mean of this and this, if they are affecting, will be significantly different. If they are affecting, again, as I am telling you, if they are affecting. Here again we come A, B and C. So, let us say B is affecting, C is not affecting that much. So, now we can say on this database, on the assumption that if we take high dose and B treatment, effect should be maximum. Now, this is called addition of effects. Now, on the other hand, it might possibly be there than that when B and the type of treatment and dose is mixed up, because in the dose we do not have ABC, we just have dose. Any medicine you take low dose, high dose. It might happen high dose of B can cause reverse effect. Now, this is not addition effect, this is called interaction. Now, again let us go there. Let us take one more example. This was example from the Excel sheet. Let us take one more example. Suppose you study, okay, and you get marks. Okay. So, when we say as you study more, number of hours, let us say low and high, your marks increases. There is another person who said marks increases when you are talking about numerical subject as compared to, let me rewrite this, numerical subject as compared to a theoretical subject. Let us assume that for the time being. Yeah, theoretical, which means marks, if you have low and high, is like this, and marks if you have numerical and theoretical, you have like this. Yeah. Now, it might happen when you combine these. We get two lines. What does it mean? We get low marks, high marks, and this is for theoretical and this is for numerical. It might happen this way when you are studying all of them together, which means for the numerical paper, if you study more, your marks will decrease. Your marks will increase if you are studying more for theoretical paper. So, this is called interaction, and for that we are going to study some plots. Now, please see, this HH means is a library. So, we have installed the library, and if there is some error, we will try to remove that also. Okay. Please see, all these things are not by default in SPSS or any other software, and the advantage of R is same software can do any sort of analysis. Okay. Now, it will ask for a mirror. So, we will go for India. You can go for anyone depending on the city you are in or the net connection. This might take a while. So, please, okay. So, please understand, this is what we are trying to do, interaction effect. Okay. We are trying to study interaction effect, and I will show you there are two ways. Please see, how do we write it? Y dependent on Z and X. Now, X on Z or Z on X, because here if you see our photo, here I drew low on the study hours on the X axis. I can also draw it like this, NT, and then you have low and high. Okay. So, the x axis changes, that is all happens here. Okay, now we have got it. So, we will copy this command and there is one change little bit. Let us say data is equal to n ANOVA data, and now we have a command like this. So, hope it works. Yeah. So, see, this is I was talking about. Please see what is happening. There are 2 levels of dosage, 3 levels of treatments. Agreed? Now, please see the first graph. The first graph is telling us that dosage, the levels are for high dose and low dose, and the y axis is, the x axis is the treatment. So, for low dose the treatment is better for all categories. You can see here properly also for this. So, as you can see here, please see properly, this is for the low, okay, and there is no effect of the type of treatment, which means, please see here, if the dosage is low, whether you do A, you do B, you do C, ज़्यादा difference नहीं है, difference है, ज़्यादा difference नहीं है. On the other hand, the high dosage does has a difference for treatment B and C. Okay? इसी चीज को हम यहां पढ़ सकते हैं. ये देखिए, लो डोसेज जब है तो सबका इफेक्ट बराबर ही है, मतलब ज़्यादा फर्क नहीं है. फर्क है मतलब पिंक वाली लाइन देखिएगा, इफ़ यू सी द पिंक लाइन, दिस पिंक लाइन, दिस हैज़ स्लाइट स्लोप, थोड़ा सा चेंज है तीनों वैल्यूज़ में, फ्लैट लाइन नहीं है. ठीक है. सो दिस इज़ वेरी इंपॉर्टेंट. दिस इज टू वे ANOVA and this is interaction effect I am trying to tell you. It is not an additive effect. The effect is not same for high and low. For high the effect is more, the difference of effect, not the value of effect. Please understand, there are two things. The value of effect is different, is lesser for the higher dose, that is very important, but the change in difference is there for the change in difference is there for the higher dose A, B, C. So now if you are doing a comparative study, अगर आप लो डोज दे दे तो कोई भी दे दो, और अगर हाई डोज देना है तो आप C दीजिए. इसका मतलब ये निकलता है, देखिए ग्रीन है C, तो आप C दीजिए. So actually either you draw this or you draw this, this both convey the same information. Okay, it's just that both of them draw simultaneously can help you a lot. Okay, please see. And this is a box plot as we know. ठीक है. See here. So this command is something new. As I told you, R has the ability to do multiple things. So I found this in the package. Okay, it is not there. Interaction effect is not there in two-way ANOVA. So we have found it the command. Please see here. हमने अब खुद ही use किया है. Okay. So we have done two-way ANOVA through CLI command line. Okay. So this is very important. We have to understand this, that interaction effects, it's something which will help us in understanding lots of things. Okay. Now I will go to something new. Theoretically right now in front of you, and I will discuss something called ANCOVA. Now, here we have to understand some concepts. Yeah. So, as we say, dose affects yield and treatment affects yield. Okay. It is also possible there is some other variable called age that is also affecting yield. Yield is the response as we are talking about. Okay. So, I now need to also make sure that among all these calculations, the age is not creating a problem with me. It might happen that people with lower age responds for low dose and people with higher age responds for higher dose, and whole calculation might change, which is what we say in COVID also, COVID times also. That was a time where these treatments, languages, all these experiments were heavily done and just told us in report, for old people we found this, for young people we found this, therefore pehle old ko karenge, फिर young ko karenge, and those sort of things. Okay. So, this is what. Now, this is a continuous variable, let's assume, because अगर age भी category variable होता तो we would have gone for a 3-way ANOVA. Okay. Now, let's talk about this. So, this is called as a covariate. So, if we have to understand yield and dose, we what will say this and this covariate age. Okay. So, this is called analysis of covariance, analysis of covariance, ANCOVA. It is not just analysis of variance, because we were discussing two types of ordinal or nominal variables or categorical variables. Okay. But now, we are just discussing that what if there is one more variable which is continuous. Okay. The arcade teaching package does not talk of ANCOVA, because ANCOVA is something which is very rarely used. ANCOVA is something very rarely used, especially in social sciences also. Most of the people you will not be understanding that they are doing ANCOVA. But I have just told you that ANCOVA can be done. Okay. And if time persists, time permits us, we will go in this detail when we go for the last class, where we are discussing the remainder of things, or how to prepare a report. That is our last part. Okay. Where we will just combine things and tell you on real time data, multiple things, how do you combine them, how do you see them, how do you. Okay. So, this is ANCOVA. Okay. So, please understand, we have done analysis of variance, repeated measures, between measure which is primarily used, repeated measure is sparingly used for us. For medical sciences it is used very much. We have shown you calculation of repeated measures. Okay. Then we did n-way ANOVA or 2-way ANOVA precisely. In 2-way ANOVA we did the interaction plot also, which is most important thing in 2-way ANOVA. If you don't do interaction plots in 2-way ANOVA, कोई फायदा नहीं है. ठीक है. And then we went to one more thing, that if the third variable in our case is a continuous variable, Then we will apply ANCOVA. We have not discussed that right now. Okay, we will discuss it in the coming class. Okay, with that I halt this lecture for the time being. Thank you.